Hofmann elimination. One type of Hofmann elimination is the reaction of a bulky strong base with a tertiary alkyl halide. In this reaction, the tertiary butoxide anion is reacting with the tertiary alkyl halide 2-bromo-2-methylbutane. This combination of reagents produces the less stable alkene as the major product. The question is, why? The reason for this must be in the transition state. There are two types of beta hydrogens, primary and secondary. Notice elimination of the primary protons produces the less stable alkene, and elimination of a secondary proton produces the more stable alkene. Let's look at the transition states. First, look at the transition state that produces the less stable alkene. The bulky base is abstracting a primary proton. There is steric interaction between the incoming tert butoxide ion and the groups attached to the tertiary carbon of the alkyl halide. Now look at the transition state that produces the more stable alkene. In this transition state, the bulky base is trying to reach the secondary hydrogens. There is now steric interaction between the groups on the adjacent tertiary carbon plus the adjacent primary carbon. There is greater steric interaction in this transition state, which makes it less stable. The higher energy transition state means that the energy barrier to form the more stable alkene is greater than the energy barrier to form the less thermodynamically stable alkene. This reaction will be slower, and thus produce the more stable alkene as a minor product.